Okay, can we code it now? So let's say there is a function count. This count returns an integer denoting the number of nodes present in the tree, which is rooted at R. So you pass a node star R over here. And now the first thing you should always write is your base case termination condition. So you should say, hey, if R is null. So you can either write R equals to null, or you can just write not of R. So if R is null, return 0. Otherwise, you can just return this expression, which is intending to say 1 plus count of nodes in root left plus count of nodes in root right. That's it, job done. I can draw a recursion tree diagram, helping you understand that how it sort of works. Let's take a look. Okay, it will make your life easy in all the upcoming questions. So let us understand. Okay, but do you guys understand how this is fundamentally correct? Forget about how the code would operate on it, but do you understand how this is fundamentally correct, this equation? Okay, so if you understand how this is fundamentally correct, just make a note of it on your piece of paper that no matter what tree question you have, you always have to think in terms of root, LST, RST. You always have to break your big tree into these three components, and you will always be able to solve it. Okay. Now I'll just give you a glimpse of how this code would run. For that, I would need an input. Let's say you have a tree that looks like this. 2, 3, 4, 5, 6, and let's say 7. Okay, cool. This is your tree, and you want to run this code on top of that tree. So you would first, let's say this is your main function here. From this main function, you would make a call to that tree for this node. So you would call count at that node, which is 2. I mean, you would not pass 2 here, you would pass the address of 2. If let's say the address of 2 is stored in R, you would pass R over here. So what will happen? You call count of 2. Now let's look at the code. This thing is not null. So this termination condition will not run. Rather, this thing will run. When it runs, then it means it will first make a call to this 3 because this 3 is root left. So you will call count of 3. And after that, you will call count of 4. Correct? Now, you might have learned how recursion works. The control comes from here to here. So now when you are at count of 3, this thing gets called for 3. Again, this condition is false. So you will come here. When you will come here, you will make a call to count of 3's left, which is 5. So you will call count of 5. And after that, you would also call count of 3 right, which is 6. Okay, before I draw further, is it clear so far, whatever I am drawing? Are you able to take some sense out of it? Yes, no? Okay. Now, from count of 3, you have come to count of 5, right? So you have come to count of 5. Again, this 5 is not null. So you will come here. You will return 1 plus. So you will call count of 5 left. What is 5 left? What do you see in 5 left? It's null. It's null, right? So you will call count of null. Correct? And after that, you would call count of 5 right. 5 right is also null. So you will call null here. So what has happened is that so far, computer knows about this much. So far, your computer has taken control from here to here, here to here, and then here to here. Now, at count of null, this condition will be true because the root is null. So you will return 0 from here. So you will return 0 from here. Similarly, at this count of null also, you will return 0 from here. Now, think when count of 5 was called, then you had returned 1 plus this thing plus that thing. Now this thing is 0. That thing is also 0. So count of 5 will return 1 plus 0 plus 0. So count of 5 will return 1 plus 0 plus 0, which is 1. And it makes sense to return 1. Why? Because I had told you the responsibility of this function is that whatever is the tree rooted at R, it should tell me how many nodes are present in that. So the tree rooted at 5 is this much, and the number of nodes present in this much is 1. That is the reason it is returning 1. This is how recursion works. The control goes from top to bottom, and the returns happen from bottom to top, and then they kind of, get consolidated as they move upwards. Is it making sense? I'll deep dive more on this, but are you guys understanding how things flow? Correct? Okay, so now you come at count of 3. Count of 5 was already done. So this count of 3 will call that count of 6 that I had written over here. Count of 6 again, according to this logic, will call count of 6 left, which is null, and count of 6 right, which is also null. So it will call count of null. Count of null. What would it return? At null, you always return 0. So you return a 0 and you return a 0. And now again, if you remember, at count of 6, you had promised to return 1 plus something plus something. Those two things are 0, 0. So you return 1 plus 0, which is 1. Again, it makes sense. Because when you say count of 6, then the number of nodes present in this subtree is 1, and that is what it has done. So every children is doing their job. Like 5 is doing its job to say that, hey, I got 1 child within me. 6 is saying I got 1 child within me. And then this 3 is saying that I got 1 plus 1 plus 1 child, which is 3 children within me. So if you take a look at count of 3, you had said you will return 1 plus number of children in left and number of children in right. Number of children in left is 1, number of children in right is 1. So you'll return 1 plus 1 plus 1, which is 3. And again, it is right, because here there are 3 nodes. Similarly, when count of 4 is called, you will first call count of 4 left, which is null, and then you will call count of 4 right, which is 7. At null, again, you will return 0. And at count of 7, again, you will make a call to count of 7 left and count of 7 right, which is count of null, you will return 0, and at this count of 7, you will return 1 plus 0, which is 1. And this count of 4 will again return 1 plus 0 plus 1, which is 2. And this count of 2 will return 1 plus 3 plus 2, which is 6. That's how things get returned. Does it give you enough clarity now, like how this piece of code runs on the tree? Yes or no? Right? So if you are clear with how recursion works, and if you can fundamentally write such kind of equations, then 90% of the job is done on trees. Okay, cool.